In this video, we're going to start taking a look at OSPF cost manipulation. Now, the cost value is going to be how OSPF determines how to get from point A to point B. And that's pretty much the only thing it does. It uses the metric of bandwidth to manipulate the cost. So a slower bandwidth is going to equal a higher value. A higher bandwidth is going to equal a lower value. So there's also another capability out here to basically take a router out of service using the maximum metric command. We're not really going to touch on that. Just be aware that you can do a max metric router LSA, and it's going to basically make that particular router look like it's not worth it. Now, when it comes to actually the cost value itself, there's three ways to manipulate the cost. From the interface level, you have the cost command and bandwidth manipulation. And at the process level, you have the auto cost reference bandwidth. So what we're going to do, and it's actually very, very easy to do, we're going to come over here, and we're going to manipulate the cost on all the routers in Area 0, which Area 0 is basically this big block of information right there. So that's where we're going to do that. So we're going to click in here, pull this up, and we're going to start on routers 1, 2, and 3, and then we'll do this on our XR 1, 2, and 3 after that. So on R1, we're going to come in here, and if we do a show IP route OSPF, actually let me just do it this way, expand this out this way, then I'll just scoot this over here, like so. That should help a little bit. Beautiful. That works. So now I can see the entire routing table of R1, well, just about most of it. You get the point. That was weird. Anyway, so that is where we're at with that. So what I'm going to do now is on R1, you can do this a couple different ways. As you can see, if you happen to have a situation where you have a particular path in the network, this is a prefix. It's an OSPF route, it's an external type 2, and we have two different ways of getting to it in the network. We can either go via XR3 or via R2. So this is where the equal cost multipath comes into play. So if I want to go in here and on interface gig 1.113, I can do a IP OSPF question mark. And I have plenty of options. I can type in the cost. I can specify the cost. 65535 will basically make this link unusable. I can also say the bandwidth command, or the bandwidth is going to be X amount of kilobits per second. I can do that as well. Now, either way is valid, but the drawback to it is OSPF utilizes 100 megabits per second is a value of 1. So by looking at this, what does this right here tell me? That tells me right there that this is a gigabit interface. Gigabit meaning what? 10 times faster than 100 meg, right? 10 times faster than fast Ethernet. So that means that a cost of 1 equals 100 megabits per second. That is going to tell me that in the grand scheme of things that is not going to be I'm not going to be utilizing the router's full potential. So what I need to do is this. I need to come up here and I need to manipulate this from the process level. So I'm going to type in router OSPF 1. I'm going to type in auto cost question mark reference bandwidth, and I'm going to assign, and this is in megabits per second, so I'm going to type in 1 gigabit. So that's going to do that. I'm going to go ahead and change this on all the interface, or on all the routers, and this is how we're going to base it off of. But if we type in do show IP OSPF interface brief, you'll see that the cost is 1, because they're all gigabit. Now, if I go in here and I change the bandwidth to be, say, 10 gigabit, now they're all cost of 10. Notice how that changes when I change the incrementation. So now what I'm doing is I've said now all the reference bandwidths are 10 gigabit. Okay, that'll work, but is that how I really want to do it? No, not at all. So I'm going to go back to 1 gigabit, and that takes me back to a cost of 1. Now, once I've set it globally, I can then go back to the interface level and specify the cost on a per interface basis. So I can go back to interface gig 1.113 and type in the IP OSPF cost is, 71. And now the cost is 71 on gig 113. So that works as well. I can also go to interface gig 1.111 and type in the bandwidth is, and this is in kilobits per second, I can say it's 10 kilobits per second. And now you'll see that that particular link is no longer valid. It's 65535. Now if I type in do show IP route OSPF, you'll see that I lost the connection between those two paths. I have to either go, right now the best path in the network is through R2. Why is that? Because both the connection to XR3 and the connection to XR1 are both worse paths. Simple as that. So that's how it would affect that. Now if I go back to the interface level and I type in no bandwidth 10, now it's going to reverse that back to that. And if I do show IP OSPF, show IP route OSPF, I'm going to have more paths added because now that route has been propagated. And then if I come in here and I go back to, where is it? Dot 13, and I type in no IP OSPF cost and do a show IP interface brief. Now they're all back to 1, and I do a show IP route OSPF. Now I have everything back installed again. So I'll have a path to everywhere I need to go, and that is how you would go in and manipulate the different metric values. It's actually really easy to do. Now this does not affect your path selection via the OSPF state machine. So if you notice that when I did the paths, I didn't lose, if we scroll back up here a little bit, I didn't lose my E2 routes, right? They're still there. I didn't lose my default route. It's still there. I just lost the additional paths that I had to some of the other areas in the network. I'm sorry, I lost additional paths that I had in the network before, and I gained them back now that I'm in that particular situation. Now, if I do a do trace to 100.7.7.7 numerically, I'm going to utilize multiple paths to get off there. So I'm going to go via R2 and XR3, XR3 to R3, and then eventually we'll get to XR4, and then eventually to R7. So I get there as I go along, but the thing here that needs to be maintained is I only have multiple redundant paths because I have set up my cost values to reflect a forwarding mechanism that will allow me to utilize ECNP. Simple answer is I made sure to scale auto cost reference bandwidth so that my minimal interface is gigabit is the actual reference bandwidth that I'm setting globally. And then they inherit that. So gigabit becomes a cost of 1. I can go in there if I have a 100 meg link, I could then specify that that's a cost of 10. And it makes things that much simpler when you're going forward and trying to scale the network. This has no effect on the type of route that it is or where it was advertised. It just simply helps you with, are you going to be choosing one path over another and stuff like that. That's how you go about getting the design in place and things like that.